show how serious the problem is. So on the left side, those are the most recent estimation about the AMR-related infections in the United States annually. And it can lead to about more than $55 billion annually. That is due to the healthcare cost and also due to the loss of productivity. And also is indicated this number, it may be likely to be underestimated. But actually the problem is not only within the United States, it's actually threatening the population globally. So you can see on the right side, it's based on the review on antimicrobial resistance. It's estimated by 2050, there are more cases that we can expect. Actually, it's death cases that we can expect associated with antimicrobial resistance by 2050. It's going to up to 10 million. So the purple part is actually the extra cases from now until 2050. You can see when it's add up to the whole numbers, it's even higher than the numbers death due to cancer or some other very pernicious infectious disease. And the total cost could be 66 trillion pounds. Okay, so let's think about where the antimicrobial resistance in bacteria comes from. And first, I want to remind you that the antimicrobial resistance is a natural phenomenon. So it doesn't mean it's always related to the human activities. It actually has been existing in the nature for quite a long while. That's because bacteria, some bacteria actually can produce antibiotics. That's their way to survive. That's their way to fight against the other bacteria. So that's trigger and provide some low degree selection environment for the antimicrobial resistance. That is nothing about the human activities. But it's generally considered there are two other ways that maybe trigger the development and existence of AMI in bacteria. So one is the use of antimicrobials for human health. So on the right side for this figure, can you see my mouse? Can you see my cursor?
Yeah.
Okay. So this is a chart. It's a little bit of small font size, but in the x-axis, that's the amount of outpatient use of a penicillin among different member states in Europe. And on the y-axis, that is the percentage of case that has been identified as a penicillin resistant with Staphylococcus pneumoniae. So you can see there is a very clear positive association between the use of a penicillin and the proportion of the case identified as a penicillin resistance. That indicates a very strong correlation between the use of antibiotic use among human beings and the resistance cases among human beings. In another source is actually main sources that all the media and the science has been focused on is the use of antimicrobials among the for animal health purpose. Particularly, there are some medicines has been used for the growth promotion purpose. Those has been critiqued the most. So on the right side, the very right side, the bubble chart, it shows based on the data from FDA among 41 different antibiotics that has been approved for the animal or livestock use in the United States. 31 of those 41 are identified as medically important for human use. So with that situation, it might compromise the treatment efficacy for if we use the same class of drugs to treat the human disease. Different exposure pathways that can lead to the human infection of antimicrobial resistant bacteria. So in the center, it is summarized as the classical pathway. So you can see from here, food is in the center, but it could be starting from the food animal where the antibiotics can be used. that could be the trigger of the development of antimicrobial resistant bacteria. And from that, the food from of the animal origin can be contaminated. And then through the consumption of the food, and then people can ingest the resistant bacteria and got infection. Or there could be another way, that's from the human being, because we also use antibiotics. We actually, as the major consumer of the antibiotics, antibiotics. And through the cross-infection, that the antimicrobial resistant infection can be spreaded among the human being ourselves. So those are the two major different source and routes considered as the classical pathways. But there's some other alternative pathways that can be considered. So for example, there's animal waste from the food animal primary production or slaughterhouse facility. And from that can contaminate the environment. It could contaminate the soil, it could contaminate the water, and all the way to some crops in the field. And as another type of food that can contaminate can get the human being infected. Or here, there's another way that's from the pet animal or companion animals, and they can use antibiotics that are relevant to the human clinical settings. Then through the direct contact, then they also can infect the human being. So here is considered as some alternative pathways. But there is another pathway here is called reverse pathway. So this means, okay, it's not only always start from the food animals. It's not only the direction like from the food animal to food or to human being. It could be reversed. It could be starting from the humans. We, among the human communities, the resistant bacteria has been developed and it can be transmitted through the waste and have the impact on the food animals and to come back to the circle. So I will say this is a relatively complete picture about the different sources and the possible transmission pathways. However, if you look at the literature, we have a very imbalanced focus.